Okay, welcome. In this group of lectures, we'll be searching for life in the universe. And so today we're going to start out with SETI, which is the search for extraterrestrial intelligence. And so I will be stepping you through this. I am your search coordinator, Robert Nemiroff, and this is a course being taught at Michigan Technological University. And the course title is Extraordinary Concepts in Physics, but you can call it Physics X. And you can find it on iTunes. All the lectures, of which there's many, approaching 50 or so, on Starship Asterisk on the web. And I tried to make this bigger so that people could read it, but I guess it didn't work out so well. So Google Docs isn't perfect yet, but you can find it if you're so enamored. So first, one of the most common things that's brought up with SETI is what chance is there? So of finding extraterrestrial life, or intelligence. So, and you can break it up into different factors. You can do this with almost anything. You can break up factors. What's the chance that you're going to have lunch in an hour, or something? But you can do the number of civilizations in our galaxies that are contactable would be one number in this. Let's go to red. Another is the star formation rate, because you'd like to have lots of stars to look at. The fraction of stars that have planets, because if you have lots of stars out there and they don't have planets, then you probably won't find life, although that's assuming that you need life to find planets. The next is the number of habitable planets per star. So let's say how do we know what a habitable planet is? Well, we don't. So in the absence of really knowing what it is, we just assume, well, it has to be like us. And we need liquid water and oxygen, so we use those. So what fraction of the above planets, if they have all the ingredients, how many have developed life? And what fraction of these have developed intelligent life, whatever that means? And then after they've developed intelligent life, for instance, dolphins, how many are contactable? So dolphins haven't built any radio telescopes of which we are aware. But we have. So we are more contactable than dolphins, I think. And the next is, how long will this civilization be contactable? Maybe they hate each other, and they're going to blow each other up real soon. So if they're only contactable for 10 minutes after they develop contactability, nobody would be calling or they wouldn't be looking during those 10 minutes. Most likely it's measured in years. How many years? Who knows if our high level of civilization, if we consider it high, how long it will go on for? All right, so you can put in plausible numbers, and you can play this game for hours until your family and friends are annoyed with you. So I just plugged in some numbers just for fun. One is that there's 10 stars per year being formed, and that f of p, so we can go back and see f of p was fraction of stars that have planets. Let's say half the stars have planets. And then let's say n is equal to 2 and go back and see, oh, okay, that's the number of habitable planets, so there's 2. Then FL is 1, where that's the fraction of planets that develop life. Let's call FI of 0.01, so I'm making these up. So you can make up your own. So that is the intelligent life. So it's rare to have intelligent life. Contactable life is again very rare. And let's say that intelligent civilizations go 10,000 years before becoming uncontactable. How many then would we be in contact with? And the answer is 10, if these assumptions. So are we in contact with 10 extraterrestrial civilizations? Not to my knowledge. So the question is, well, why not? Where are they? So this was coined over lunch. Now I just want to say that a lot of good things get coined over lunch. So many times when you sit there and work on what you're supposed to work on, you do great and you make progress on your project. But sometimes over lunch or some downtime, you come up with crazy ideas that then become better known possibly than much of your work. Although that's not true of Fermi. Fermi did a tremendous amount of good physics, and this is somewhat whimsical. But that's one of the more important topics of today. So he asked over lunch, where are they? If there's all these intelligent civilizations, they should be everywhere. You walk down the street, you should see all kinds of green antennaed aliens trying to shake your hand. So why don't they communicate? So this has been thought of. So there are possible solutions to this, and we don't know. I'm just going to throw out a few. One is that human civilization is unique, and this could be because of chance. It might be that some of those numbers in the Drake equation, they're actually much lower, and we were guessing at them, but if we could actually calculate it in some more fundamental way, the numbers would come out much lower, and we're lucky to even have existed. Theology comes into it, and that's a hot topic, so we'll just leave that go right here. High-tech civilizations destroy themselves, as I mentioned. So then that would lower the amount of time that these civilizations are available to contact. High-tech civilizations might destroy each other. So once they find out about each other, they say, oh no, those are the Klingons over there or something, or the Daleks. So we need to fight to the end. And then both civilizations end up back where they can't reconstruct the kind of technology needed to contact outside life. An interesting correlate was given by Sagan in that many people think, especially in science fiction, that when two civilizations meet, they're going to have tremendous wars that are really cool and photogenic and things explode. However, Carl Sagan pointed out that most likely one civilization will be much more technologically advanced and militarily superior than the other. So for instance, when we meet dolphins. So we don't have any beef with dolphins. We're not fighting dolphins. We don't really compete very much for resources with dolphins. So even though we're both comparable intelligence, if we were to have to battle it out, sadly enough, we'd be able to probably take out the dolphins. And we're doing a pretty good job not trying to battle out with them because we're getting stuck in tuna nets and things like that, tuna fishing nets. So we are militarily superior to the dolphins. It's not a battle. There's no fantastic laser light shows going on where things explode. And possibly when two civilizations meet in the universe, it'll be something like that. One will just be much more superior than the other militarily. So another possibility out of the Fermi paradox is the universe is naturally dangerous. There are supervolcanoes. There are collisions with asteroids and minor planets that could take out human civilization without a problem. And if you don't believe me, just ask the dinosaurs. And if you can't find a dinosaur, well, that's the problem, isn't it? Okay. So maybe high-tech civilizations choose to remain quiet. They do so because if they were to broadcast out, one of the higher-tech civilizations might come and stomp them out. Maybe there's a Star Trek-like prime directive, and I tie this into what's called the zoo hypothesis, that we're somebody's entertainment. They're listening to our radio broadcasts, they're watching us through some kind of telescopes or something, and it's entertaining for them. They don't want to bother us because we might want to grow up and be our own civilization, but they have their reasons for not contacting us. Maybe we don't hear about them because they become energy efficient. Way back when there was the introduction of radio and television, we were broadcasting signals that went everywhere, including well out into space. But now, we don't do that so much because we have cable TV, so we've gotten more energy efficient, and we don't broadcast our energy out into space. Maybe a high enough civilization gets so energy sufficient that they don't, good at preserving energy, they don't broadcast out, so we're not going to hear them. Maybe we can't understand their communications because it's an alien. Have you ever tried to understand a dog? So it's tough. They bark and stuff, and they mean something sometimes, but it's really tough to understand them. Maybe aliens are so alien we don't know how to get in contact with them. Maybe we don't know how to search. We're listening in the radio with radio telescopes, things like that. We're going to other planets. Maybe we're just doing it wrong. Maybe their signals are out there, but the signals look just too much like noise to us. So if you compact any signal, it's only the inefficient signals that don't look like noise. If you compact a signal to have the maximum amount of density in there, then essentially you use up all the bandwidth and it looks a little bit like noise. Okay, this gets fun. Von Neumann probes. Maybe the civilizations aren't out there. Maybe they died, and they created self-replicating spacecraft that travel around the universe and replicate themselves until they do even more of themselves. And so there are people who debate this, and there are papers in the literature. Von Neumann, a famous mathematician and scientist, came up with this. One argument against this is if these things run rampant, they'll start absorbing a large fraction of the rocky planet mass, making themselves into von Neumann probes. So another update of this is maybe they're partly biological, and this was called by Freeman Dyson, coined as the Aster Chicken Project. So here's a ponderable for you. Maybe DNA is some sort of von Neumann probe. and that you don't have to build the whole probe, you just have to build the building blocks and it will build itself in some ways. Maybe. Okay, so we've been listening. So this is the big ear that was put up a long time ago, one of the first searches for extraterrestrial radio signals, and the first thing they did is, one of the first things they did is they found a radio signal. Frank Drake himself found one. But it could have been someone in the parking lot playing games by turning on and off their ignition, or not. We don't really know what the problem was. But there was some sort of signal, has not been replicated, and so people are skeptical that it was truly extraterrestrial life. This is the Very Large Array, which is not generally used to search for extraterrestrial intelligence, but it was used to film the movie Contact, and is occasionally used. Every now and then they take one of the dishes and they do something with it. But it's not all that big compared to other radio telescopes. Here's one of the big dishes from VLA. So here's the Arecibo, the largest single dish radio telescope in the world, which is in Puerto Rico of the United States. And so this is the big dish which fills in a valley, and it's really cool, and they upgraded this, but it still works the same. And so they look occasionally, it's not their prime thing they do, every now and then they take some data and they look through it for some kind of signals that would tell you about, tell that there is extraterrestrial civilization out there. And so you can actually analyze these signals yourself. You don't have to ask them to do it. You just go to SETI at home. I think they're still running. And I know Michigan Tech used to have a whole team that used to be one of the top teams in searching. This used to be a screensaver of mine and many people, but now I've stopped it, and I think many people have done that. So your computer in its spare time when you're not using it can actually search through Arecibo signals for extraterrestrial intelligent life, and they haven't found anything convincing, or you would have heard about it. They do find things they don't understand. So here's one they don't understand. This is a plot of frequency, two-dimensional frequency plot. So this is a signal that looks like it could be something. Most probably it is some kind of communication satellite, possibly a military satellite, that people didn't know about when they were searching, and maybe the military isn't volunteering information about. So there's reason to believe that this is not extraterrestrial signal, but they do see signals they don't understand all the time. What you need is a gold-plated event, it's called. You need something that repeats and that is obviously some kind of code, maybe a sequence of prime numbers or something like that, and is seen by other telescopes. So we've gone out and we've sent what's called a message in a bottle. So the Voyager probes included this disk that says things about us here on Earth. I'll go a little fast because I'm running low on time. We occasionally broadcast out signals. This was done by Drake and Sagan, was broadcast out from Arecibo many years ago, and here's the message that was sent. And you can actually spend time trying to figure that out. It's kind of fun. Some of it you get, some of it you don't. This is a person, this is DNA, these are numbers, just to give you a start. So other people have done this as well. That was not the only attempt. This is called the cosmic call. And this is actually, again, you go by ones and zeros and you build up this pattern because you do two prime numbers. And this is actually defining numbers, and then you can try to figure out what these are. It's fun. You can go to APOD on the web, the APOD for 2006, April 2nd, and check into that. And this is the last slide. So the Arecibo message, the one with the in colored there, although it wasn't sent in color, this one, was sent toward M31, a globular cluster, but unfortunately they forgot to account for proper motion. So they meant to broadcast it here, but they ended up broadcasting it about there. But still, there are stars there, and maybe one day, I guess in 100,000 years, we might get a response or so. So with that, I will leave you to ponder ways of creating astro chickens and extraterrestrial intelligence. Bye.